Hi, this is Dan Wiebe, and this video is the first episode of Testing Tools for MASQ. Today we're going to mostly be talking about TNT, and our audience for this video is first of all people who have time to volunteer. And by that I mean, seriously, if what you're interested in is just trying out the software to see how it works, or satisfying your own curiosity about it, you're certainly welcome to listen to or watch the rest of the video. But this isn't really oriented toward you. This is toward people who actually want to be part of the MASQ team and contribute to the work that goes into MASQ. Also, we need you to be willing to use the command line. If you're afraid of the command line, that's okay, as long as you're willing to work through that fear. It's not that terribly difficult. But if you're testing MASQ, you're not going to be doing a lot with graphical user interfaces, at least not for the foreseeable future. We would also like people who are not MASQ developers. If you're a developer, that's fine. We just don't want you to be a MASQ developer if you're a tester, because probably the correct term is not quite conflict of interest, but if you're thinking about MASQ from the viewpoint of a developer, then it's going to be harder for you to think about it from the viewpoint of a tester. If you develop something else, on the side, or maybe for your main job or whatever, that's fine. That's fine. You can still think about MASQ as a tester. If you're not a developer at all, that's, at least from some perspectives, even better. Because you won't even be tempted to think about MASQ as a developer. We specifically need people who can think like users, and people who can think like attackers. Because developers, we developers, we try to think like users, we try to think like attackers. We're not. Those impressions or those efforts are contaminated by the fact that we're developers. It's good to have people who are uncontaminated by the knowledge of exactly how it works, so that those people can try out things like, does it work this way? Does it work that way? How about this thing that he never thought of? Those are the sorts of people that we would like to use as testers. Also, right now, this particular tool that we're talking about, TNT, it doesn't work on Windows. So you'll need to use a Linux machine or a Mac machine to use it. And you don't want a really small one. I talked to one fellow who said that he had a Windows machine. His main machine was a Windows machine, but he was going to do whatever he could to help. And what he was thinking was he'd run TNT on his Raspberry Pi, which was a Linux machine, and do it that way. Well, a Raspberry Pi just doesn't really have the power to test several nodes at once. And so Raspberry Pi is not big enough. An average Linux or Mac laptop, maybe it's big enough, maybe it's not, but Raspberry Pi isn't. A desktop machine with 32 or 64 gigabytes of memory, and it is fine. Mostly what we want is memory. We haven't really looked for minimums, but I would say probably if you have less than 8 gigabytes of memory, might be a little hard. But that's just a guess. Also, the people who work as testers, we want them to be willing to indulge a certain amount of formality. We have processes mostly in place. We still need to complete the definition of those processes. But we do have processes that will ensure that when a card actually goes into production, into the production branch, it'll have somebody's name on it that says, I certify that, this card works the way it's supposed to. If you're not willing to be that much a part of the team, again, you're welcome to watch and enjoy the rest of the video if you want. But mostly we're after people who are interested in leaving their mark on MASQ. Okay, so what is this TNT thing that we keep talking about? The first thing that might be puzzling about it, I think, is that sometimes it's called cluster tool, and sometimes it's called TNT. What's that all about? Well, back when MASQ was forked from Substratum's Node, we knew that we knew that Substratum Node was a trademark that we couldn't, for legal reasons, we couldn't keep that name, so we had to come up with our own name, which we did, MASQ, but we didn't know whether there was a trademark on TNT or not, or the TNT stands for TestNetTools. I don't think I've said that before. We didn't know, so we decided that we might rebrand that as well, and so we started just by calling it Cluster Tool, and I think the only thing that's called Cluster Tool about it right now is the repo name, the GitHub repo name. There may be a couple of other things, but mostly it's called Cluster Tool in the GitHub repo name. But it turned out that wasn't really an official trademark. There's nothing wrong with just continuing to call it TNT, which is, what everybody knows it by anyway. So eventually we're going to change the cluster tool, all the cluster tool references back to TNT, but we haven't gotten around to it yet. So you'll see it called both things, but they're both the same. I mean, they're two different terms for the same thing, and cluster tool is deprecated. So we're here in this video. After we finish with this item that's showing on the screen right now, we're just going to call it TNT and not cluster tool anymore. So TNT is only intended for testing. It's almost useless for production. Once you hear what it does, you may think to yourself, oh, this is interesting. If I want to run a stable of nodes so I can make a bunch of money, then I should do it with TNT. And I would discourage that just because TNT isn't really oriented in that direction, and it's liable to have enough functionality to get you into trouble and not enough functionality to get you out. You're welcome to try it if you want. I certainly can't keep you from doing it. But what we really ought to do, if that becomes, running a stable of nodes is a thing that lots of people want to do, there ought to be a separate tool for that. It may use some of the same code that TNT uses, but it should be a separate tool. So TNT is a tool for starting and monitoring multiple nodes. It starts them the way you tell it to start them, and connects them the way you tell it to connect them, or a default way if you don't tell it, and then just watches them run. It can do this in a number of environments. For example, it can do it. It can start nodes on virtual machines in Amazon Web Services or in the Google Cloud. If you have leased virtual machines that are running there, that takes a little money. So since MASQ is not a funded project, at the moment I don't believe MASQ actually has any, owns any leased virtual machines either in AWS or in Google's cloud. However, it can also run nodes in VirtualBox virtual machines. VirtualBox, in case you don't know, is a virtual machine hypervisor that can run right on your desktop or laptop and start up any number, subject to memory constraints, of virtual machines on your system, and each one of those virtual machines can run a node. But that's really not what we're going to talk about here, or that's not what we're going to be mostly using it for, because we're going to be using Mac and Linux to run it with Docker. If you don't know what Docker is, that might be something to go pursue. I won't say much about it here, except that it's kind of like VirtualBox in a way, except that it's more limited to VirtualBox. It can only run operating the quote virtual machines unquote that it starts. Can only run the same kernel, the same operating system kernel that your main operating system is running. But in being limited that way, they're also much faster and much less resource intensive than VirtualBox virtual machines. They're called Docker containers, not virtual machines containers. Docker is perfect for what TNT needs to do. So how does TNT work? Well, as a user or a tester, you're going to start up TNT, which is a Python program. And when you direct it to, TNT will start up some number of nodes that's specified by you. It can be anywhere from one node to dozens of nodes. And these nodes are called node 0, or node dash 0, node dash 1, node dash 2, up to node dash 24 or node dash 57 or whatever it is. And those nodes, once they come up, of course, each one of those nodes will start its own log. And if you leave them alone and you let them start up the way they want to, they'll start that log in trace mode. So the logs get pretty big pretty fast. And then TNT will suck in information from all those logs and use that information to generate reports and graphs for the user, and also just let the user look at the logs. And so you can tell what's going on in the nodes. You can see each node's view of the situation, and just tell what's going on and whether your test is passing or failing. So what's the present condition of TNT? It is definitely test harness code and not production code. So it's not designed to be. It's not designed for its UX. It has a. I don't mean that to sound like it's shoddy, because it's not shoddy. The UX is certainly approachable and it's informative, but it's not the sort of UX that you're used to seeing in command line programs. It takes a little bit of getting used to, but of course, once you get used to it, it's pretty quick and easy to use. It's pretty configurable. It could be a little more configurable, and there will probably be cards to make it more configurable, and some of those cards will no doubt be generated by testers like you, and run by developers probably like me, and then tested by testers like you. But right now it's what do I want to say? It's capable of doing the stuff that it needs to be able to do, perhaps with one exception. That there's a card already for, but the card hasn't been played yet. It is test-driven. There are tests for TNT. You can, once you have TNT downloaded, you can type ci/all.sh, and the tests will run, and you'll see whether they all pass or whether some of them fail. And any future changes to TNT will also be test-driven. It is potentially Windows compatible. There's nothing that we're doing in TNT that is just absolutely impossible in Windows. But when we wrote TNT back in Substratum, when Substratum wrote TNT, we really didn't have any Windows development machines. And so we never really made it Windows compatible. There's nothing that says that it can't be Windows compatible. It just isn't. And Windows compatibility may be a direction that we decide to go in the future if it turns out that we can't get enough testers to do what we want to do in Linux and Mac. But here's a whole, here we get 24 more testers if we can make it Windows compatible. That would probably be enough to bump up the priority of that to a place where it would actually get done. But right now it's not Windows compatible, so you have to do it in Mac or in Mac OS or Linux. Also, it's about 85% operational. By that I mean that there's functionality in it that, how do I want to say this? When the functionality was put in, it worked just fine. But since then, it hasn't been used. And so probably it doesn't quite, the system has changed underneath it, but nobody's needed to use that functionality because that testing functionality was used to get the system over a hump that it is now over, and it doesn't have to go over that hump again. And so nobody's used that functionality, and so it sort of has decayed and doesn't quite work anymore. I don't think that will turn out to be a problem. in the future, but if it is, it can certainly be fixed. So, like I said, this is test harness code. It's not production code. It's not meant for, it's not meant for people to bang on and try to attack and destroy and so on. It's meant to be used as a method to try to attack and destroy the node. So that's the intended production software. So that's a picture of what TNT is and how it's used and how it operates. We'll get into examples next. Okay, so the first thing to do is to go to GitHub and look at the MASQ-project, and you'll see our front page. If you scroll down, you see 3 repos. This is the actual node code. This is the Ethereum contract for the sub token, which I don't expect will get much activity, but we're interested in cluster tool, so click here. And you get the cluster tool repo. You'll notice that here is the code. Here are the setup instructions, which are going to be important, but not right this instant. But the important thing for right now is this clone or download button here. You want to click that. You want to make sure this says clone with HTTPS. Which is a good thing, and you want to get this string here on the clipboard, either with Command or Control C, like this, or you can click this button, in which case it goes onto the clipboard as well. That's the important thing here. For the next step, you will need Git installed on your system. If you don't have that, go figure out how to do that and come back. All right, the next step is to find a directory under which you want to install TNT and navigate there. I'm using this directory because I already have TNT installed in the system, of course, but I'm going to reinstall it here under this MASQ video directory. There is nothing in this directory right now. What you want to do is type git clone. This is, of course, assuming that you have Git working on your system, and then paste that URL that you got from GitHub, and hit enter. And now, if I do an ls, you'll notice there's a cluster tool directory. If you like, you don't have to, but if you like, you can rename cluster tool to TNT. And if we cd in there and look, there's the TNT code. So this is a good place to start following the instructions from the README file on GitHub. So let me figure out how I'm going to do that in the screencast video. Here are the instructions for installing TNT. You'll notice here that you're going to need Python on your system, version 2.7 point something, basically not version 3, version 2 point latest, which is 2.7 point. I'm not sure what the actual latest is, but it's not right now. It's not compatible with Python 3, so don't install Python 3. Probably you already have Python 2 installed on your Linux or Mac machine. To find out, just go to a command prompt and type Python, and if you get an error message that says Python isn't installed, then you need to go figure out how to install Python. If you do have Python installed, it'll put you in a REPL that you can get out of, I think you type exit with parentheses or something like that. If you try to get out and you can't, it'll tell you how to get out. This part here about SSH, we don't really need that to use Docker. Probably you already have SSH installed on your machine again, but we're going to use Docker, and so we won't really need SSH, so I don't really care whether it's installed on your machine. Here This is definitely required. We do have to install a bunch of Python dependencies. I'm not sure that I'm going to get much out of this on my machine because, like I said, I already have Python installed on my machine, but let's see how it goes. Okay, so back in the command window, let's do a CI setup. And oops, it looks like I don't have pip installed. Pip is a package manager for Python. Let's install that. Okay, let's try CI setup again. And there, I've got the requirements installed. Let's go back to the README and see what's next. Okay, so it looks like the next thing to do is to install, oops, didn't mean to do that. Next thing to do is to install Graphviz, which is the thing that makes the graphs of the neighborhood. It's probably going to look a little bit different on the Mac. You might use Homebrew to install it on a Mac. I don't really know. I don't have a Mac, but it should be fairly easy to go to the Graphviz website and figure out how to install it on your Mac. So let's go do that. Like this. And there's Graphviz. Cool. Let's go look at the next step. Okay, this particular piece of instruction here is, this is kind of misplaced. We don't care about this until later. So here is, this here is mostly concerned with if you're going to run TNT using Amazon Web Services or the Google Cloud. Which we're not here. That might be for episode 2 or episode 3. But just so you understand where this came from, when TNT was first developed, it only worked with Amazon Web Services. Then Google Cloud was added to it later. Then Docker was added to it, and then VirtualBox was added to it. So at the beginning, it worked with paid cloud services. And of course, if you use paid cloud services, then there are secret keys and stuff that you have to use to connect to them that you pay for. And what this TNT config thing is, it's the file that holds your secret keys. So TNT config, of course, is not distributed with TNT because we can't tell what your secret keys are. So we can't distribute this file. However, we distribute this file, which, if you look at it, is a version of TNT config that's empty, that doesn't have any secret keys in it. So what you do is take this empty version and you copy it to here so that you actually do have a TNT config.py. And then if you were going to use cloud services, you'd go in there and fill it out with the various secret keys and stuff from your cloud services, and you would absolutely not ever upload that to anywhere public because, again, it contains your secrets that you don't want to share with the world. So you just keep that on your machine and don't ever share it with anybody. Now, for episode 1 here, we're just going to be using Docker, so we won't have any secrets to worry about, and our setup will be pretty simple. We're just going to do this copy, and we're going to forget about this because it doesn't apply to us just using Docker. So here we'll just type cp like this. Now we have a tnt.config or tntconfig.py, and that's all we need for that step. Okay, this next step is only for people who are running on the Mac. It turns out that TNT needs to control your terminal window in order to be able to execute commands in your terminal window on the nodes that that TNT is in the herd that TNT shepherds. And the default terminal that comes with macOS doesn't allow doing that. A lot of people have iTerm installed just because iTerm is a bigger, better terminal that has more capabilities than the default terminal program, terminal application. So TNT needs iTerm. If you don't have iTerm installed, then you should install iTerm before you try using TNT. TNT will just use iTerm if it's installed. If it's not installed, I don't know whether TNT will crash or whether it just won't let you do the stuff that it probably will crash. That's my guess. So again, if you have a Mac, make sure you have TNT or make sure you have iTerm installed. Probably if you're a Power Mac user, you already have it, but if you don't, just install it. These next few sections, we're not going to use it with Google Cloud here, or at least not in episode 1. But if you want to set it up in Google Cloud, you'll want to take a look at this. If you want to use it with Amazon Web Services, take a look at this. Want to use it with VirtualBox here. To use it with Docker, which we do, we have to build the Docker image. If you're not familiar with Docker, of course, in order to do this, you'll have to have Docker set up on your system. That's not a particularly trivial thing to do. You'll want to, there's a different way to set it up on Linux and on Mac. If you don't have it set up, you do want to set it up, and you want to set it up so that your user is a member of the Docker group. The reason you want to do that is because the Docker group will have special privileges so that you can type Docker commands without running sudo. TNT will not use sudo to run Docker commands. Therefore, if your user is not a member of the Docker group, TNT won't work for you. So that making yourself a member of the Docker group, the Docker installation instructions will make that kind of optional. Because Docker will work without it. You just have to, all your Docker commands have to have sudo on them. But TNT doesn't do that. So for TNT, that membership in the group is not optional, it's required, which means that after you install Docker, you will most probably have to at least log out and log in again. You might even have to reboot your system. So do that. And then we'll go and see about running this setup Docker thing to create the image from which the containers will be spawned. So we'll run CI setup Docker here. We're downloading the image from probably Docker Hub. So that should do it. Now let's see if the tests pass. And they do. So Docker is installed, and I'm sorry, TNT is installed, and its tests pass. So now that TNT is installed, before we actually show some examples of using it, let's talk about that formality that we were mentioning earlier a little bit and show you what I meant by that. Let's go click on MASQ project. So now we're back to that front page with the three repos. Look up here, see how it says projects. There's one project, click on that, and we have MASQ Node. This project is linked to both Node and Cluster Tool. So click on this, and now you see our card wall. So I want to talk a little bit about our card wall and how it works for folks who are part of the MASQ project. It has several columns. This is the new column. All new cards, every single new card, always goes in the new column. Backlog is cards that we have. You'll notice there's 63 cards in here. New, there's 20 cards in new. There's 63 in backlog. Just to run through them very quickly. You can probably freeze frame and see all these. I don't really want to get into all that's here. Backlog are cards that we're going to do at some point in the world. We're probably going to do at some point in the future. It could be that sometime between now and then we'll decide not to do those cards, but probably we're going to do these cards. However, we can't do them right now for some reason. There's something we need to do first. Some other card needs to be done first, or there's some design work to be done, or they don't have good testing plans, or somehow they're not quite ready to be started on. That's why they're in backlog. Ready for development are cards, again, that we're going to get to, or probably going to get to at some point. These cards are ready to go right now. There's no reason why we couldn't just pick any of these cards in this column and just get started on them. The only reason we don't is because they're not at the top of the priority list. This column, awaiting development, it's empty right now. This isn't a real good example. The reason it's empty right now is because I'm doing this on Thanksgiving Day. So the holidays are upon us, and we're not keeping this full the way we should. This should always have a few cards in it. How many cards? It should have about as many cards as it takes to do in an iteration, maybe plus one or two. In other words, enough to keep us busy. And the cards in this column should absolutely, the order matters. The one at the top is the highest priority. The next one is the second highest priority. So if you're a developer and you're on the MASQ project, then when you finish a card, you come to this column and you take the top one. You don't have an option to skip the top one and take the next one. You always take the top one, because it's the most important. Dev in progress, prepare testing demo. That's what we're doing right now. That's this card. This card is in progress. There's only one card in progress because right now there's only one developer. That's me. So you'll notice that this one actually has a name on it. None of these others should. Wait a minute. Actually, this doesn't have a name on it. It was opened by me, but it should also be assigned to me. You should see a little picture of me here. I have to fix that. Assigned to me because I pulled it into this column, and I'm currently working on it, as you can see, because you're watching this video and stuff. Well, actually, once you're watching this video, this card won't be here anymore. Anyway, once this is done, then it goes into this awaiting review column where somebody connected with the MASQ project will pull it out of here and review it, and either put it back if it doesn't pass review, or it'll go in here if it's being reviewed, and it'll either go back if it doesn't pass, or it'll go forward if it does pass. And here's where you guys come in. Once it's in here, once it's in this column, awaiting quality quality assurance, then one of you, hopefully, will notice that it's in there, pull it, put your name on it, and put it here in quality assurance in progress. You'll notice this column is empty because right now, as I'm making this video, we don't have any testers. One of the reasons I'm making this video is so that hopefully we can get some testers. You'll check that card out and test it and make sure that the change that card implies is actually, is actually in place and working. And if you find a problem with it, you'll move it back. Exactly where you'll move it back to, we'll talk about later. And if it's good, if everything's fine with it, then you'll move it here, and it will actually go into production, into the production branch. Done this iteration, there's a number of cards that are done. And later we're going to be showing how to test one of these cards. Now, these cards have actually not run through tests because, well, not run through QA tests because we don't have any QA people, and that's not a good thing. Hopefully, soon after this video is released, we will have a stable of QA people who will be able to justifiably put cards in this column that we are confident work and do what they're supposed to do. Right now, these cards have all been tested just by developers, which is not ideal. Hopefully we can make that better. So that's how the card wall works. More specifics about that have to, well, the meeting, the card wall is modified. Usually the card wall is modified by meetings, or at least the beginning part of it here is modified by meetings. And the meeting that does the most is the grooming meeting. At least once an iteration is 2 weeks, at least once an iteration we have a grooming meeting, which is generally on Zoom. So you'll, if you want to participate in the grooming meeting, you'll want to install Zoom on your machine, and you'll get an invitation from Kaori Hero, and wind up in your Zoom meeting. And a grooming meeting consists of 3 parts. The first part is that we take all the cards that have accumulated in new since the last grooming meeting, and we move all of them either to backlog or to ready for development. That's the first part, and always we completely empty the new column. So a card in the new column goes into backlog if it can't be started on right now. If there's something that it's waiting for, if it's like too big and needs to be split up, or if it's like waiting on, so it needs a license for something and we don't have the license yet, so it'll go in backlog until it gets the license, or if it doesn't have a decent test plan and the test plan isn't one that can be stuck on, it's not short enough that it can be stuck on during the grooming meeting, it'll go in backlog until it can get that, or whatever. It'll go into backlog if it can't be started on immediately. If it can be started on immediately, then it goes right into ready for development. So that's the first part of the grooming meeting. From new, basically the first part is emptying the new column. So once the new column is empty, we go on to the second part of the grooming meeting, which is taking ready for development and moving into awaiting development. So this is mostly the product owner's responsibility. This is Kaori Hero is going to do a lot of this. We go down ready for development and pick out the cards that we want to prioritize next, sort of as a group, a big hunk of cards that, well, not necessarily a hunk, but several cards anyway, that we know we want to work on next, the next bite of work, and stick it in awaiting development. And presumably at some point on his own time, Kaori Hero will arrange the cards in this column in priority order, so the most important ones at the top and so on. But that's the second part of the grooming meeting. We take a few cards from here and put them in here, enough cards so that we we have enough work to do to take us through the next grooming meeting when we'll have more stuff here. And then the third part, if we still have time, the third part of the grooming meeting is going through the backlog cards and figuring out which ones of them have we all of them in here will have something that needs to be done before they can go and ready for development. And the next part of the grooming meeting is picking the ones picking the low-hanging fruit out of backlog and doing whatever has to be done to these to put them in ready for development. And usually the grooming meeting will have a specific time that it ends. Especially for MASQ, where people are going to be all over the world, and some people are going to be on really late at night, and others really early in the morning, and we can't, we want to really respect people's schedules and so on. So the third part of the grooming meeting is we'll move cards out of backlog until the grooming meeting is over. However many cards we get out in that time, that's what we do. So that's a grooming meeting. Moving stuff around in these first, 3 columns? 4 columns. Moving stuff around in the first 4 columns of the table, of the card wall. There will also be, intermittent design meetings, and mostly the design meetings will be developers. But we probably will need at least one testing person, one QA person in each of our design meetings. The purpose of a design meeting is exclusively to move cards from backlog to ready for development. Cards that need enough work that it takes a special meeting to do that work to get them over. And some of whether it's done in a design meeting or whether it's done in a grooming meeting, one of the things that all these cards are going to need in order to get from backlog to ready for development is some kind of a test plan. And by a test plan, I mean, once the card is finished, the tester needs to be able, the QA tester needs to be able to tell whether the additional functionality in the card works or not. If there's no way to do that, then the card shouldn't make it from backlog to ready for development. If somebody tries to take it out of backlog and put it in ready for development, a tester should stand up and say, hey, wait a minute, no, you can't do that because I can't tell. Once you do that, based on what it looks like right now, I can't tell whether it works or not. You got to redesign this card so that we can test it once it's done. And so then it gets modified, and maybe it turns out that testing is figuring out how to test it is a hard problem, and so we need to think about it for a while. Or maybe it's pretty easy, and we can just just quickly dash off a test plan for it. And in some cases, it could be that testing it is either trivial or not necessary. For example, if it's a documentation card, it could be that just a review is enough, and it doesn't. I mean, how do you test documentation? I suppose you could say, well, I read it and see if I understand it. Well, yeah, but that's kind of review. So some of these cards will specifically not have testing plans, but you don't want a card to accidentally not have a testing plan. You want to make sure that you do that on purpose if you do it. So that's the formality that we need to make sure that when a card gets to here, quality assurance in progress, that whoever picks it up actually knows what to do. Because figuring out what to do from the contents let's just pick a card. One of these guys, like this one, for example. Show more. Currently, the node can migrate data from older versions of the node to current versions, and to a limited degree, data from newer versions of the node to current versions as well. Just sort of read this. How would you test this? Modify the node so if it comes up and finds a database whose schema version is older than current schema, you probably, as a tester, you read this and you don't really know what it's talking about. And the reason you don't know what it's talking about is because you're the kind of person we want, in other words, not a MASQ developer. If you were a MASQ developer, this would make all sorts of sense to you. But if you're not a MASQ developer, this is probably reasonably opaque. So as a tester, if somebody tries to move this card to ready for development, you should object and say, hey, wait a minute, this is not clear. I don't know how to test this. Add some stuff here that is a test plan, or explain to me exactly what this means, and I'll put in the information to say how to test it. But you can't, as a QA person, you can't depend on developers to be able to do that for you so that you understand it. I mean, we'll do our best, but we're not testers. And so that's why we need testers in our meetings, so that you guys can stand up for yourselves and say, hey, thanks for what you did, but it's not enough. You need more. So that by the time it gets to the place where it needs to be tested, you can test it. One other thing that I should point out is that by the time it gets to, well, actually, no, I think I'm going to wait on that because I think I've got an example of it coming up. So I think that's it for the card wall. Next, I think I want to take a look at pipelines. So pipelines is dev azure, well, it's right there, /masq pipelines. This is our CI, our continuous integration service. If we go in and look at here and list the pipelines, here's our pipeline for Node. I don't think there is a pipeline for TNT yet, but if we go in here, we see some failed runs and a passing run. Let me just show you what this looks like. When we run one of these, we have a Linux run, a Mac run, and a Windows run. And if we go into one of these, we can see all these stages that ran for Linux. We initialized the job. We checked the stuff out from CI. You can see all that stuff here. Then we looked in the cache to see if there was some stuff already there that we could use. It turns out there wasn't for this one. And because there wasn't, we had to install the tool chain for building Node. I don't particularly want to go into detail there. There's some configuration for Git about who the user in the email is. We don't have to disable annoying Windows services because this isn't Windows. We're preparing the Node build here in various ways, creating directories and such, and checking, doing some static code analysis. Here's where we build the node and run the unit and zero hop integration tests. Then here we'll run the multi-node integration tests. Here we collect and publish the results out to MASQ results. Then here we store away whatever it is that we like, right here where we installed the node toolchain. Here we're going to store that away so the next time we run it, it'll be faster. This post-job checkout thing, I don't really know what that is. I don't think I care. This is a finalized, that's pipelines, that's not really us. And the Mac, if we look at the way the Mac thing went, it's very much the same thing. I won't bother opening all these up and looking at them. Here, this one, we didn't have to install the node toolchain here because here we actually got some stuff out of cache. There was some stuff there. Windows, well, we got some stuff out of the cache for Windows too. We did not have to install the node toolchain here. We did have to disable the annoying Windows services because this is Windows. But you see how it runs on all three of them. You can see it took 56 minutes, 21 minutes, and 33 minutes. So I'm not going. The 56 minutes is because we ran the multi-node tests in Linux, and we don't run those anywhere else. So I won't wait for the whole thing, but I'll just so you can see what happens, I will run this pipeline again. This is not normally the way it runs, but I'll run it by hand here, and you can see the tests are starting up. We're looking for a VM to build for Linux, a VM to build for Mac, and a VM to build for Windows. Okay, so it looks like we found our Windows and Linux VMs, and now we found the Mac VM. So that's how that's working. So while that works, this is more a developer thing than a tester thing. As a tester, you might want to watch something run through here. You probably won't be actually starting things through here as a tester. But I wanted to show you, just so you know how things work. When this gets to the stage where it does collect and publish results, we'll wind up at github.com/masq results, like right here. The results will wind up here. See how there are 3 of them, Friday, November 29th, day after Thanksgiving. That's today as I record this. And these are those succeeded builds. So as a tester, you will want to look at this site and you'll want to download this thing. So I'm going to go ahead and download this guy by clicking on him, and here he comes. Okay, I've got him. Okay, here's the result. I decompressed that file into generated Linux, and inside that is this generated folder. Inside that are these 4 folders. These 3 are mostly of interest to developers because they have sort of intermediate results from tests in them. This is the one that we're interested in. It has our 2 binaries in it that we want to copy into our TNT installation. So let's do that. Here's the TNT installation. You'll notice there's a binaries folder here that is at the moment empty. Of course, we don't actually put any binaries in there because it's TNT's job to test binaries that you install there. So we'll copy in the stuff from downloads, generated Linux, generated bin, everything in there we'll put in our binaries. And now we see those 2 files in. And so the next thing to do, I think, is to actually run TNT. This part is going to be a little interesting because TNT starts up Windows, and so far we've been recording just one window so that the text is big enough that you can read it. So I don't know exactly what we'll do here, but let's do Python. This is how you start. Start TNT, Python testnet.py, and there it is. Printed out a whole bunch of stuff to start. It says we've configured these Google Cloud instances, these Amazon instances. Of course, we haven't set up anything there. Also, no VirtualBox instances, but here's a whole bunch of Docker instances. As you'll notice, they're named after Pokemon. I forget whose idea that was. It might have been my idea, actually. But we found a file on the internet that had a bunch of Pokemon names, and just as we start the containers, we name them after Pokemon. That's probably, it turns out not to be a particularly useful thing with Docker. It's much more useful for the machines to have names in Google, Amazon, and VirtualBox, but at least they have names. So here TNT wants to know, do we want to run in the cloud? Do we want to run VirtualBox, Docker, or blank to exit? So we want Docker. And it says, how many instances do you want to use? How many nodes do we want to start? Well, I'm going to start 7 containers here. So if you look at what that just did, it set up Bulbasaur, Ivysaur, Venusaur, Charmander, Charmeleon, Charizard, and Squirtle. So those are containers that are running now. They don't have nodes on them yet. This is the time, and this is help, available commands. These are what the commands that you can type now and what they do. It's reasonably friendly. Here is the time when you would configure the various nodes to, start up exactly the way you wanted them start up. But I'm just going to start them up vanilla for this little demonstration. And I'm going to say start all. Now I could say start node 0, node 1, node, like that, but I don't want to. I'm just going to say start all. And here they're starting. Each one in its own container. Now you'll notice, if we look at these start messages, here is here's a node descriptor. Node 0 start, this is interesting. Node 0 starts on IP address 2. See that? Node 1 starts on IP address 3. Node 2 starts on IP address 4. That's always the case. So if you have your IP address, the last IP address digit here, you can tell what node dash that is by subtracting 2. So the last one to start up here, here 8. And this was node dash 6. And we started 7 nodes, nodes 0 through 6, so we used IP addresses 2 through 8. So now what do we want to do? Well, what I think we'd like to do here, without stealing too much thunder from another demonstration that's going to follow, is I think we want to just run some data through the system and watch what happens. So that means we want to tail node 0. And you can't see what this does because we're only looking at this window, but what that actually did was pop up another command window with a tail-f in it of the log file. So as that log file, it shows where the log file is right now, and as the log file continues, we'll get more information there. I will see if I can bring that up here. Okay, here it is. Here's the log file. You can see it has the name and the IP address in the title. I think it would probably be better if it just said node-0. But anyway, you kind of get used to it after a while, so it doesn't matter. So here are a bunch of logs. This last log here looks like a bunch of gossip. Is that what it is? Well, it is. It received gossip. So it received all this gossip. Finished processing gossip about 6 nodes. Yeah, it ignored this gossip because it already knows everything that's in there. Okay, so here's the log. So I'm going to now move back. I can't really show you both of them at once. So I'm going to move, well, no, I won't. I'll keep letting you look at this one, and I'll go back to my other window, which you won't see, and I will type curl in it, C-U-R-L, node-0. I'll show you this command later after it's already done. And so what it does there is it subverts the DNS on Bulbasaur and gets ready to run a curl on it. In other words, gets ready to consume some data on it. And it asks me how many curls for Bulbasaur. I'm going to say 1. There's a so that you don't have to type your own URL for curl. There's a built-in URL. If you curl the built-in URL, what you get is there's this website that has a page that tells you the first million digits of pi. And that's the page that gets curled in. So I'm going to do that. You watch what happens here in this log. I'm going to hit enter right now. Okay, now there's a whole bunch of stuff that just ran by that you didn't see. I will roll back and show it to you in the log. These are the debts that got accrued to the wallets for all the CORS packages that just went. So here are the CORS packages. I don't want to take too much time. Is this a return route? Yes. Don't want to take too much time looking at all of this stuff. That can be a different video. However, there's a return route message here, and we can see that the exit node was the one with this public key. Started with Q2DR. Okay, so if we wanted to look at before we did this curl, we had no idea which node would be selected as an exit node. But we want to go find the node that's got Q2DR, come on, node descriptor, public key. So let's go back and look for that. Okay, I told you I'd show you the curl command. It's right here. I typed curl node 0, and then it asked me how many curls. So I just typed 1, but I could type 10 or 100 or whatever, and it does them one after the other. If you want it to keep consuming for a while you watch it and do something, you can type in as many as you want, and it'll keep doing them. But we only needed 1. But let's roll back here to look at these. Come on, here, Q2DRV, that's the one that we're looking for. That's node 6, right? Because this is IP address 8. So that's node 6. Let's go do a tail of node 6 and see this from the other end. Okay, again, this popped up another window that you guys can't see because you're only looking at this window. Let's go find that. Okay, notice that this is Squirtle, and it's IP address 8, and here's the log, and here it's charging all the exit services that it provided. Here's all the data. Well, actually, here's some real data. And so on. You can see this stuff. If you were here with me, you would be able to see this stuff actually roll into the log. Because of the limitations of the screencast, I can't really. Well, I suppose I could if I set it up, but you have to trust me. You see the data roll by. So that is well. Let's go back to. Let's go back to the main window for a moment. Okay, here's the main TNT window. I'm going to get out here, and before I get out, I want to kill all the containers. So I'll just say kill all. Makes you feel like a megalomaniac, right? So there go, and it was something that you weren't able to see was that the two tail windows that I had up for Bulbasaur and Squirtle disappeared when the containers they were tailing disappeared. So now nothing is running except TNT. TNT is waiting for our next Next command, I'm just going to hit enter here, and I get a prompt back. So that's a very simple run of TNT. We just started up a network of 7 nodes and ran a bunch of data through it, and looked at the near and far end of that, the logs for the near and far ends. We didn't look at any of the logs in the middle, but we could have, once we found that routing message, we could have seen, well, it went through this node and this node, so let's go look at those logs. Something we could have done, we just didn't. And I think I forget exactly what's coming up next, but I think it's another example. All right, now let's talk about actually testing a real card. Let's go look at the card wall again, github.com MASQ project. Okay, here's our front page again. Let's look at projects, MASQ Node. We've done this before. Here's the card. Oops, what just happened? You may not have seen that actually. I put another window up over this one, but you may not have seen. If I don't know how the screencasting thing works. So if you were doing this yourself, you would be taking a card out of awaiting quality assurance and moving it into quality assurance in progress. But one of the reasons I'm making this video here is that we don't really have any testers yet. So I'm going to grab a card from done this iteration. Here's card 146, here's our card 161, 143. We'll try 186 because I've already sort of taken a look at this one. Remove dead nodes after a decent interval. So here is here's the description. Sorry, but I'll read this. Dead nodes are kept in the neighborhood database to ensure that they're not accidentally added back in while processing gossip from nodes that don't yet know they're dead. Arrange to have them expire from the neighborhood database after enough time has passed that we can be reasonably sure gossip about their newly dead state has propagated throughout the network. Suggestion, don't make a special, I don't care about that. That's to developers. Doesn't have anything to do with testing. So, you would be if you had pulled this card, you would need to test this behavior. There's an example of something bad here that doesn't show. So I'll just warn you about that, and we'll encounter it together later. But if you think about this, imagine that you saw this card not here at the end, but you saw this card earlier at the beginning of the card wall in a grooming meeting or a design meeting or something, and it was your job to figure out how to test this. How would you test it? Well, it seems reasonable that you would use TNT to start some nodes. You wouldn't actually have to run any data through those nodes for this. You just use TNT to start up nodes. You'd look at the neighborhood to see how it was connected in the database and in the gossip, and then you'd kill one of the nodes and look and see if there was any more gossip, if killing the node produced gossip. And if it did, you'd look at the gossip and see if the dead node was in the gossip, and if it was, what was connected to it, and look at the databases, and look at a few databases and see if the node was in those databases, that sort of thing. And if everything happened okay, then you'd say, oh, all right, this card is approved. And if you noticed problems, then you'd move the card back and put a comment on it saying, no, I noticed these problems. So let's use TNT to take a look at this. So let's start up TNT again. All right. We'd like to run in Docker. Let's start up 7 nodes again. Well, actually, that's 7 containers. That's just the containers. We haven't started the nodes yet, but let's go ahead and start them. Okay, here's something we haven't done yet. Let's take a look at inspect. Let's inspect. Oh, node 0 is handy. Inspect will, well, I'll show you. It says it just scanned through the log for node 0, and it says there are 17 logs about the neighborhood database changes for Bulbasaur. Which one do you want to see? Usually you want to see the latest, but you can take a look at any one if you want. I want to see the latest, so I'm going to say 17. Now, I don't know if I don't know how that's set up, but I'm going to show you the window that just popped up. So here is the neighborhood as it as node 0 sees it. Here is node 0. You'll see it's on IP address 2. And you'll also see things like how node 0 knows the IP address of this node because it's right next to it, this node because it's connected, this node because it's connected, this node because it's connected. It does not know the IP address of this guy because it's more than one hop away, or this guy. So just so you know, this A and R, they have to do with consume only and originate only. This V2 means this is version 2 of the information about this node. There was a version 1, but it's been superseded. Here's version 4, version 3, version 4, and this is the first few characters of the public key. It's not the whole public key. It's just, I guess it's the first 8 characters of the public key, and then if we know the IP address and clandestine port, it's listed here in this third line. So as you can see, these are all connected up with double connections. If you kind of squint, you can sort of see how this works out to be a bridge girder shape. This is one end of the girder with just two neighbors. This is the other, also with 2 neighbors, and it's connected. The very end is connected to something with 3 neighbors and something with 4 neighbors. Here, this guy is connected with something with 3 neighbors and something with 4 neighbors, and everything else has 4 neighbors. So we'd have to like move this around and stretch it out a bit, but it'd turn into a bridge girder if we looked at it. We could look at this from another vantage point, but instead of that, let's try killing off, what is this, node 1? Let's try killing node 1 and then seeing what happens. Okay, here's the TNT window again. I do not want to see any more neighborhood database neighborhood databases right now, so I'll hit enter. It says, okay, so what do you want me to do? I want you to kill node-1. And I know it's node 1 because the IP address was 3, so that must mean node 1 has IP address 3. So there we go. Now let's take a look at inspect node 0, just because node 0 is handy. Ooh, look at that. 20 logs about neighborhood. Remember how it was 17 before? So there was, they gossiped about that kill. That is something, that's something to mark down and say, okay, well, we killed a node and there was gossip about it. What does that gossip look like? Well, let's take a look at, we're not looking at gossip right now, we're looking at databases, but let's take a look at 20th database version of the database. Okay, let me switch you over to that window. Okay, here we are. Here's node 0. You'll see that node 1 is, well, maybe you remember from when I was showing it to you before, but I've still got it up here where you can't see. So I'll tell you the public key for node 1 is WJYX. In other words, this is node 1. So you see node 1 is still in the database, but nobody is acknowledging that node 1 is its neighbor. Node 1 is still in the database, and it still is claiming that all these are neighbors, but nobody else is acknowledging it as a neighbor, and so of course no traffic, at least not here from node 0. No traffic can go through node 1 because none of these arrows are bidirectional. But it's still in the database. It hasn't been removed from the database. The card said after a decent interval. Maybe the issue is just that the decent interval hasn't elapsed yet, but we can see that it's still in the database. But this makes me wonder, what did the gossip look like that made this happen? So let's go. Let's see. Actually, let's take a look at node 8. I'm sorry, node 6, IP address 8, which is far enough away from node 0 that node 0 doesn't have its IP address. Let's take a look at that. Okay, so we're done looking at stuff for node 0. Let's inspect node-6. Only 6 logs. Which one do I want to see? Well, I want to see number 6. And here it is. Just a moment. So the gray one here is node 6, and we see WJYX, that's node 1. Same thing here. Even though node 6 here is nowhere near the node 1 that blew up, or that we killed, it still knows about it, and it still knows that it's not to be used. So at least that part's okay, but node, it's still in the database. Let's see if we can figure out how node 8 found out about this. Just a moment. All right, we're done here. Let's look at, well, did I say node 8? I meant node 6, IP address 8. I do that a lot, I'm sorry. Whenever there are only 7 nodes started, node 0 through node 6, so if I say node 8, I'm probably talking about node 6. Okay, so let's see how we have an outbound command, an inbound command, and an inspect command. Inspect shows us the condition of the database, the neighborhood database in a particular node. Inbound and outbound show us gossip that is either leaving that node or arriving at that node. Outbound is leaving and inbound is arriving. Gossip looks a little bit different from a database. Let's take a look at the gossip that was inbound to node 6. Inbound node 6. There are 15 logs about gossip messages received for Squirtle. Again, what happens here is that TNT goes and runs through the log for node 6 and identifies all the messages about that have to do with incoming gossip, and it's found 15 of them. So it says, which one do you want to see? Well, I want to see the latest one, so I will say 15, and I got a pop-up here. Let's go take a look at that. All right, here's node 6. Oops. No, this isn't. Gray means something different here. So here, the last gossip that we received was gossip from node 3. It's IP address 5, so that's node 3. Gossip 2, node 6. So whenever you see a gossip diagram, you'll always see these two things here somewhere that are connected by an arrow with a hollow head. This is where the gossip came from. This is where the gossip arrived. So over here, this is what's in the gossip itself. The one that's gray is where the gossip came from, and this may look a little weird. This is where wait a minute, is that right? Yes, this is where the gossip arrived. The fact that it doesn't have any border around it means that there's no actual information about this node in the gossip. There's information in this node that it has this node as a neighbor. But it doesn't actually, I mean, for this node, for example, there's information about the flags that for incoming and consume only. There's information about the version. There's information about the public key, information about the IP address and clandestine port and so on. There's a bunch more information that doesn't show up here too. But one of the pieces of information that's in this node is the fact that it has this node as a neighbor. Which is why you have an arrow out to this node. This guy has no circle around it because there's no record, no specific record in the gossip for this node. The reason for that is if you're gossiping to me, if you're gossiping your database to me, your database must include a record for me. Because you have to know about me to gossip to me. But you're not going to tell me anything in the gossip. You're not going to bother telling me anything about me because I already know everything about me. As a matter of fact, I know it better than you do. So there's no need to waste the space telling me about me. So you're going to leave me out of the gossip that you send me. So that's why there isn't any information about this node in this gossip. However, if we look for that node that's missing that we killed, WJYX, you'll notice that it's not there. It's not there. It's gone. We're not gossiping about that node. And everything that we are gossiping about has a double edge. Well, except these arrows aren't doubled, but that's again because you're not telling me anything about me. If you were telling me about me, one of the things you'd tell me about me was that I had an arrow to here and I had an arrow to here, but that you're not telling me that, so because I already know that, so it's not in the gossip. So what we're seeing is the node that was killed is gone from the gossip, but it's still in the database. So what does that mean? Well, here's the issue that I was talking about before. The fact is, we decided when we were doing the development work on this, we decided to just leave it in the database. Because the thing that was really killing performance was not that the databases were getting so big that memory couldn't hold them anymore. The thing that was killing performance was that the gossip messages were getting so full of dead nodes that they were 200, 300 nodes long, and it was just really, really unwieldy. So we figured, look, as long as we don't gossip those nodes, it doesn't really matter if they stay in the database, and if they do stay in the database, then that's we do get the benefit of if we get an old gossip message or a message from a node that hasn't sent gossip in a while or received gossip, and that node thinks that the dead node is still alive, it doesn't show up in our database again. We've already got him in there, and we know that we don't have a connection to him, so we're not going to revive him accidentally because of the version number. So just to keep the version number in the database, we decided to keep the node in the database, but the card doesn't say that. The card should have been changed during development to say that we made that decision. And if we had testers, the testers would complain and say, hey, I noticed that this card doesn't do what it says it does. And then we would have had the argument, well, do we make the card do what it says it does, or do we make the card say what it actually does? I think the right answer there is to make the card say what it actually does. But what I want to get from this is that if we had testers, we would have a defense against this. Now, after this video is done, I'm going to go change that card because it's a bad example and I want it fixed, but it's another reason that we want testers. Okay, so I guess that's about it for this for episode 1 of Testing Tools for MASQ. In the description, you'll find a link to the community Telegram channel for MASQ. If you're interested in being a MASQ tester, if you're on Telegram already, just come to that channel and tell somebody, post a message saying, "Hey, I want to be a MASQ tester," and we'll get you set up. If you don't have a Telegram account, go to the URL and make yourself an account. We would love to have you. We look forward to seeing you, and if you've stuck with us for this long, thank you for watching the video. Goodbye.